Hi, I'm Sumyadeep, and this is HydroWatch, a multi-agent system that catches water contamination before it becomes a public health crisis, built with Google's Agent Development Kit. Across rural India, health workers test water sources for contaminants like fluoride and arsenic. But that data almost never gets analyzed as a trend. Contamination builds up slowly over months. By the time someone notices, the source has already been unsafe for weeks. That gap between data being collected and someone actually watching it is the problem HydroWatch solves. This isn't a job for one AI model. It needs 5 different kinds of reasoning. Understanding messy field notes, spotting a slow trend across readings, applying a safety rule transparently, deciding how urgently to alert someone, and answering questions about it all conversationally. So HydroWatch uses 5 separate agents: intake, pattern, risk, alert, and query, each handling exactly one job and handing off cleanly to the next. Here's how it flows. A volunteer submits a raw reading. The intake agent normalizes it and logs it through our custom MCP server. The pattern agent pulls the source's full history and checks it against WHO and BIS safety limits. The risk classification agent, using deterministic, auditable rules, not an LLM guess, assigns a severity tier. And the alert agent decides whether to notify a health officer with built-in rate limiting, so the system never spams the same alert. Let me show you it actually working. This is the dashboard. You can see sources monitored across several villages, color-coded by risk. Clicking into a source shows its full reading history against the safety threshold. But here's the real proof. I seeded one source with a slowly rising fluoride trend, 5 readings, and ran it through the pipeline 1 reading at a time. Watch the classification. Normal, normal, watch list, and only on the 5th reading, immediate hazard. The system flagged this as a trend to watch, 3 readings before it actually became dangerous. That's the entire point. Catching it early, not reacting late. This was built end-to-end in Google Anti-Gravity, using Google ADK and Gemini to orchestrate the 5 agents. The system deploys to Cloud Run with BigQuery and automatically falls back to local storage when cloud credentials aren't available. So it works just as well in a low connectivity field setting as it does here. The technology to catch this kind of slow-moving risk isn't exotic. The thresholds are public. The math is simple. What's been missing is a system patient enough to actually watch it. HydroWatch is a second set of eyes that never gets tired, never misses a slow trend, and never lets a warning sign go unnoticed until it's too late. Thanks for watching.